Hello, and welcome to Prisms Algebra 2. I'm your host Echo. Today, I'll be taking you on a guided tour of Chapter 12, Quadratic Relations. In previous chapters, we already learned about linear relations, which algebraically can be represented by the function y equals kx plus b, and geometrically can be drawn as a straight line. We also explored the relations between the function and the graph. Coefficient k determines how steep the line is, and constant b determines where the line intercepts with y-axis. In this chapter, we are going to learn quadratic relations in the similar way, algebraically as equations and inequalities, and geometrically as figures with certain properties. Quadratic relations have connections with a wide variety of ideas, include parabolas, hyperbolas, circles, and ellipses. A parabola is a set of Dahlia, what the heck are you doing? Don't you know that I'm making a math video? Can you just be quiet?
Sorry, Echo. I was just playing and reverse, and it's so difficult. Could you please help me?
Haha, let me help you. You know, the path of a shot or a tossed object, such as this red bird, is part of a parabola, so you just need to aim carefully before shooting. Let me show you. Wow, you win!
Echo, you're so good at this game.
No, I'm just good at math. Oh, what happened?
Maybe the light is just short circuit again. Fortunately, I always bring a lamp with me.
So bright! Do you know that the lamp is also related to parabolas?
How so?
Well, if a parabola is rotated in space around its axis of symmetry, it creates a three-dimensional paraboloid. The lampshade of this lamp is a paraboloid. Energy emitted toward the lampshades from the light bulb reflects into uniform straight beams. We name the position of the light bulb the focus of the paraboloid.
Focus?
Actually, focus is a key point to understand parabolas. All the points on a parabola are equidistant from the focus and the directrix. You will know the specific definition and function of parabola in this chapter. Oh, a castle! Oh, the light is back. Hey, do you know that the seismic waves are roughly concentric circles?
Of course I know. Don't forget that I'm also good at math. Concentric circles have the same center but different radii. When an earthquake occurs, various kinds of seismic waves radiate in roughly concentric circles from the focus, the point below Earth's surface where the earthquake began. After reaching the surface, seismic waves travel along the ground in concentric circles around the epicenter, the point on Earth's surface above the focus. Warning systems for earthquakes are triggered by measuring seismic waves with an instrument called a seismograph. Anyway, circles are one of the easiest quadratic relations. You have learned about unit circles in trigonometry before. In this chapter, you will know more about circles, such as how the coefficients affect the size of the circles and how to speculate the interior and the exterior of a circle.
Hey Echo, hey Dahlia, there you are.
Hi, Coach.
The good news is the earthquake is already gone. Also, nobody got hurt. Would anyone like to play some football to celebrate?
Sure. Let's go.
Yay.
Jay, let's go and change first. See you in a minute.
Alright,
Bye, Coach.
see you guys.
Yeah, don't you think that football is somehow related to ellipse?
Haha, let me tell you about this. While spherical balls come from the two-dimensional shape of a circle, footballs are formed from a two-dimensional shape of an ellipse. If an ellipse is rotated in space around its major axis, it creates a football. Most sports use a rounded ball because it is symmetric. No matter where I hit it, it will always have the same response. However, the design of football makes it unpredictable when it hits the ground. It also allows the football to travel through the air more smoothly and more accurately.
Wow, so amazing! I want to try. Thanks.
Chapter 12 mainly talks about quadratic relations. In this chapter, you will learn 4 kinds of basic quadratic relations: parabola, hyperbola, circle, and ellipse. You will also learn the relationship between their functions and graphs. This is an important and useful chapter. We hope you have a good time studying this chapter. Goodbye.